All right, so welcome everyone to this webinar. We're very grateful for you guys taking time out of your day to join us today. Just do a short round of introductions of us students that are hosting this webinar to begin with. My name's Eliam and I'm a second year MSc Physio student at University of Birmingham.
Hi everyone, my name's Adam. I'm a third year physio student from Coventry University.
Hi, I'm Daisy. I'm a second year physio MSc student at University of Birmingham as well.
Hi, my name is Fab. I'm a third year Coventry University student.
All right, so the goal of this webinar we have organized because as students, we feel there is a lack of information and support aimed specifically for students. So we've created a safe space for students to learn more about the science of the vaccination and have any of your questions answered. So back in November, the vaccination as a condition of deployment, or the VCOD, was announced, stating that it would be a legal requirement for all healthcare workers to be double vaccinated against COVID-19 by April. However, there has been a U-turn announced by the government, and there are discussions now focusing on whether new staff need to be double vaccinated to be employed. So vaccination as a condition of employment, and this is going to have a large impact on us students. So the aim of this webinar is to provide you guys with information regarding the vaccine, provide you with a safe space to express any concerns, and signpost you to appropriate resources. We also want to understand and gain insight into your attitudes, perspective, and beliefs towards the vaccination, which we will do through our discussion later towards the end. So the format of this webinar will be a 15 to 20 minute presentation by Dr. Donald Palmer, who has kindly agreed to join us today. Followed by that, we'll have a Q&A. You guys will be able to access the chat and use that to post your questions, and we'll try to get that answered by Dr. Palmer. In the last 30 minutes, we'll have a student-only discussion. And then at that time, we will welcome you to open your cameras and turn on your mics so that you can join in on the discussion. I'll now hand over to Daisy and she'll do a short introduction of Dr. Palmer.
Okay, so I'll just quickly introduce Dr. Donald Palmer. So he's an Associate Professor of Immunology at the Royal Veterinary College, University of London, and Honorary Senior Lecturer in Immunology at Imperial College London. He is a Fellow of the Royal Society of Biology, on the editorial board of numerous scientific journals, and is currently the Education and Careers Secretary of the British Society for Immunology. He is also the co-founder and director of Reach Society, which is an award-winning social enterprise that aims to inspire young people to fulfill their potential. So welcome, Dr. Palmer, and thank you for being here today.
No, can I say thank you to you for inviting me, and so professionally well done. So thank you, and also thank you for all of you taking the time to listen to my South London dulcet tones. So I'm going to share my screen. It worked before, so let's see if it works. So I think so if someone gives me the nod. So can you all see this? Okay, brilliant. So what I thought I'd do is to tell you a bit about COVID, immunity, and vaccines in general, and really what I thought I'd try and get for me to start was really to tell you my journey, and what I want to try and do, more importantly, is to stress that I'm really not here to force anyone to either take or not take the vaccine. I see as an academic, my role is really to provide the necessary information so one can make an informed choice. So this is purely a voluntary capacity, so not being paid by anybody here. But I thought I'd share my journey because that's really how I got involved. So this is I realize this is perhaps a rather busy slide, but I feel it was, when I was thinking about what I should say, I wanted to say how I got involved in this. So I'm an immunologist. I've been an immunologist for a number of years now. I teach veterinary students. I teach medical students, I teach biological students. So I teach immunology to a number of students. I've got PhD students, master students. So my area of research is in aging of the immune system. So as you get older, your immune system gets weaker, giving seminars, etc. And I really got involved in sort of public engagement when in fact I live in Brent, northwest London. It's one of the most diverse parts of London. And what happened, sadly, with COVID, so initially there was this idea, particularly amongst diverse community, when COVID was starting to rise and the numbers were starting, some of you may recall, there was this idea that, hold on, folks from diverse background, it doesn't seem to affect us. So that was one bit of misinformation that was starting to appear early 2000, 2020, wow. And then in the first wave, hopefully you can see this report, this is in The Guardian in April 2020, where almost 40 people died on a street called Church Road in northwest London. And this area is very pertinent to me. My barber's is round the corner. And so this was a real shock. Equally, Norfolk Park Hospital, again in northwest London, where I did my PhD, was the first hospital in the UK, I believe, to go under emergency measures. So here was a disease that was really coming through the heart of the community. And how I got involved in discussion was, and this is my friend, Professor Winston Morgan from University of East London, was starting to report, and perhaps you're all aware of vaccine hesitancy. And I don't call it hesitancy, I really refer to it as agency, particularly amongst diverse communities, about what's the vaccine about, and starting to question. And it's really related to trust in authorities. And then I got involved because someone said, look, Donald, we're really not sure about this vaccine. We don't really know much about it. We just need some information. And so that's how I kind of got involved. Primarily it was, immunology. You're a member of our community. Can you help? And so I've done over 50 of these discussions with community groups, with faith groups, in Brent, in Hackney, and so forth. And part of what I try to do is just to make sure people get the appropriate information so that they can make an informed choice. And considering the amount of misinformation that's out there. And I'll describe some of them for you as we go through this talk. So that's how I got involved. And I just felt a sense of responsibility, given in my area, a number of people from my community that got COVID. Because as I said, at one point, the idea does COVID exist was that kind of misinformation that was coming through. So, and one of those misinformation was the idea, and I remember talking to some faith groups earlier on, was this is just like flu, which partly related to the symptoms, but most folks thought, well, it can't be that serious. So I thought I'll show you this data from the Office of National Statistics, which is independent of government. So I think it's important to recognize that. And this is like earlier on. And so this is looking at the proportion and sadly the number of deaths. So I hate to start the discussion in such a morbid fashion, but I just wanted to show this slide to you, and there's the link. And in most of the slides, there's links, and anybody want any links, I'm more than happy to share. But here's something really important, because everyone's talking, like, it's the same level of death in flu. So I just want you to see this graph. This is taken for a period between January and August of 2020. And you can see the significant number of individuals that are sadly passed with COVID in comparison to pneumonia and influenza. There's just no comparison in terms of the magnitude And that's something that I was sharing and discussing with folks. And partly what you know, there was a natural lack of understanding is the fact that science is rapidly evolving, and science doesn't stay still, and science is never absolute. And I think that's been one of the difficulties in society in general, because I think we've grown up to think science is absolute. And you guys, as scientists, you study a branch of science, will recognize that science is always about challenge. So what you think works today may not necessarily work in the next week or the week after. And that was one of the difficulties people were understanding, and equally understanding viruses and the immune system. And so let me remind you what viruses do, because what viruses do is viruses can't grow outside the body. They're not like, say, bacteria that can divide. What they have to do, they have to go inside cells, and I'm sure you're all familiar with this, and literally hijack the cell machinery to make more viral proteins. And that leads to cellular destruction. But we have a powerful immune system that actually is involved in providing protection. So think of a virus as, someone's coming into a house, burglaring it, causing havoc and ransack. Whereas antibodies, a bit like bouncers at the front of a club, they're not letting any sort of undesirable folks in. So what antibodies do, and we all make antibodies. These are soluble proteins that literally coat the virus and prevent the virus from getting in. But there's also another important cell, another white cell called T cells that are made by the body. And what T cells do is that they actually destroy the cells that are actually infected by the virus. Okay, so there's various ways in which the immune system can actually deal with any sort of pathogen. But here's the real problem with our immune system, and I hope you can see this, is that we're talking about T cells and B cells. So we're talking about what we call the adaptive arm of the immune system. So the immune system consists of two parts: our innate, which is our first line of defense, followed by our adaptive immunity, which takes up to 7 to 10 days. So what happens, and I hope you can see this, is that, and in red is the key. So what happens when you get a primary infection? Viral load will increase. And this is without vaccination. But what is key is eventually your immune system will start to generate an immune response. But normally viral load kicks in first. So the generation of what we call this effector response will vary considerably. It will vary with age. It will vary with our own health. So we know, for example, as you get older, your immune system gets weaker. And sadly, as you can see with COVID, had a disproportionately impact on older individuals. Okay, so what's really important to give our immune system a chance is the role of what we call vaccines. But importantly, to get you thinking about how the immune system works, the concept is that's referred to as what we call immunological memory. So when you see the microbe for the first time, you're generating these army of antibodies and cells. But upon subsequent challenging of the microbe, your immune system has already made antibodies. It's already made T cells. This is what we call, as you can see on this slide, virus-specific memory. So now your immune system says, "Hold on, I remember you," and it will destroy and remove it more rapidly. And what vaccines do is actually, and the role of vaccines is actually to prime your immune system, so that when you do meet that virus or you do meet that microbe, you've already got now antibodies and T cells that can actually deal with this. It's a bit like, someone training for a marathon. And most people who train for a marathon actually run long distances. You just couldn't do it straight away. So what vaccines do is train your immune system. And basically, this is related to, and what happens here with vaccines per se is that by generating an effective immune response, what that basically means is if you do get infected, you can still actually have the pathogen in you. Vaccines don't prevent a microbe getting into you, but more importantly, viral load, if we're talking about viruses, will be substantially reduced. Transmission, because you've got less of it, will also be reduced, but more importantly, disease severity will be substantially reduced in comparison to if you're unvaccinated or if you are seeing the microbe for the first time. And that's one of the key things, is that if you generate this immunological memory, that's really based on how healthy you are. And that's something we can comment. And we know the importance of vaccines. Let me remind you about measles and the fact that anyone who was around, and I've spoken to older folks, my mum included, in the 50s and 60s, measles was a terrible thing. I'm going to come back to measles because there's some worrying statistics. So measles coverage is now well over 90%, and measles doesn't cause a problem. And similarly, diphtheria. You've got diphtheria, whooping cough, polio, diseases that really cause major problems, but now substantially reduced by the power of vaccination. And what this does, by getting so many people vaccinated, you generate the concept of herd immunity. And what that means is that, because everyone's vaccinated, everyone's protected, there's a reduction in transmission, reduction in disease severity. Eventually, there'll be few people that actually will carry the disease. And therefore, transmission of identifying, folks that have either been unvaccinated or naive is going to be very limited. And we know that the impact of that, for example, with smallpox, which was eradicated in the early 1980s. And just to remind folks, this is vaccine coverage in the UK. We've been using vaccines for so many years, and this is UK, and this is worldwide vaccination. And many people have argued in terms of public health, second to clean water, vaccines have proved immensely important in that regard to infectious disease. And there are, research still, going on to try and find a vaccine, for example, for malaria. But let's talk about COVID, because that's why we're here. But I thought I wanted to give you not just my journey, but tell you a bit about immunology and how the immune system works, because this is quite important. Because often when we talk about COVID, people talk about, my natural immunity. I'll get natural immunity. And basically, what we mean by natural immunity is basically either immunity through natural infection or immunity through vaccination. That is still your immunity. So the idea of natural immunity is not correct pronunciation. It's natural infection. So it's basically, if you get infected, not just with COVID, but with any microbe, will you generate a robust immune response? So if you meet that microbe again, you're able to develop protection. The key thing, however, if you're going to be infected by a microbe, is there's a potential that the microbe can cause real damage, can cause real harm. So it's really important to understand, and there's a lot of research and science of being naturally infected with a whole host of organisms in comparison to vaccination. And so the British Society for Immunology, this is a charity, they're independent from government, they're the largest collection of immunologists in Europe. I've produced a large number of fact sheets. And again, they recognize the issue of trust. And so a large number of people have been involved in producing these fact sheets, including myself. And more importantly, all the material is based on what we call peer review, which I'm sure you're familiar with. So in essence, these are research that have been looked at by a number of scientists. And if you use PubMed, which I'm sure you do as a search engine to identify research papers, you type in COVID-19, you'll see there's just been hundreds of papers, and I'll come to that in a moment. But but here are some important facts to know about your immune response to vaccine compared to a natural infection. Now, with natural infection, you may or may not generate an immune response, and that immune response will vary. So you're probably aware that in some individuals earlier on that were infected with COVID, so a good friend of mine, he got infected with COVID and he was thankfully okay. It turns out he was a high producer of antibodies. Yet his brother, who also got COVID, was a very low producer, didn't make, a very low antibody, and was also, not well. So the immune response you get is varied. Okay, so that's something which is really apparent. Whereas with vaccination, overall, you will generate an immune response. Again, like with all medicines, nothing is 100%, and that's really important to recognize that. All right. And so one of the things, however, in terms, therefore, of the idea that in terms of then of length of protection, again, this varies. With natural infection, yes, you will develop antibodies, but it would appear they wane over time. And what COVID is doing is trying us to understand this concept of what I call immunological memory. COVID seems to be a different type of virus in that respect. Whereas generating a vaccine, you seem to have at least slightly longer sort of length of protection. And equally, one of the things to think about when you compare naturally infected towards vaccination. And yes, indeed, vaccines, like all medicines, there are side effects, and it's important to recognize that, right? But equally, if you get naturally infected, there's also some side effects, and one of those it can lead to, sadly, death. And as we know, the figures in the UK and worldwide. So again, it's all about risk, which is really important. And so here's the information about COVID-19 in terms of the vaccines, the different types of vaccines, the ingredients. One of the sort of misinformation was that it contained gelatin. And so various folks from different communities naturally wouldn't accept that. But again, that proved to be misinformation. This also tells you the number of people that were involved in the clinical trials. And I should say it's the largest ever, one of the largest ever of folks been involved in the clinical trial for any medicine of human consumption. And I'll speak about that in a moment. Equally important was if you look at the folks that were involved in these trials, they're again of diverse communities. And that's again really important. Again, also the age range. And this differs very considerably to the majority of medicines that we consume, which I'll speak about shortly. This is the early studies. So these were the early studies that were done around, how effective is the vaccine? Does the vaccine work? And this slide, hopefully you'll see that. So in terms of how this is done, you get two groups of people, you give one the placebo, you give one the vaccine, and then you literally follow them in terms of do they get disease or not get disease. And as you can see with the placebo, they will, get symptoms of COVID, along with also those that are vaccinated. Really important, because that's what the data was saying, was that even when you're vaccinated, you can still get COVID. However, more importantly, look at the difference in terms of severity. So some people will still get COVID if they're vaccinated, but it's the reduction of severity. So these were what the data was saying, but then by the time it got into the public, some of that messaging was lost. So I thought I'd show you the raw data from the publication. And what's quite interesting is a large number of publications are actually publicly available. So one of the key questions people often ask is how come it was done so quickly? What is it? And so here are a number of reasons. One was the funding, the huge volunteers, more volunteers were involved in clinical trials. The science, a lot of people came together to study and analyze this. I had colleagues who at Manchester University, at Imperial and others, where people were coming in and they were taking blood and looking at the cells to try and work out what was happening. So this was, sort of science, that was happening right on our doorstep. And so that the concept of team science is something that is now being sort of shouted out and being strongly admired. Here's one of the key thing, and why was it so quick, is that in order to do any medicine that's for human consumption, it requires it to be done in the lab. It requires animal experimentation, and I know this is one of ethical consideration, and a lot of people are concerned with the use of animals, but unfortunately this is still the situation. And then it goes through what we call phases: phase 1, phase 2, phase 3. And one of the reasons why it takes so long is to actually recruit individuals, do the study, then they have to be assessed by regulators. And so going through all these procedures can take up to 7 years. So they're just literally done in series, one after the other. What was done with COVID, and as you can see from this slide, is literally they were done in parallel. And more importantly, there were so many people that took part in clinical trials, which is one of the major stumbling blocks of getting folks to get involved. And as you can see, phase 1 was done simultaneously with phase 2 and phase 3, but all the regulatory procedures were still carried out. So the results were looked at, everything was studied. But look at the difference. So again, when folks say, look, has safety been compromised? The answer is no. So I'm going to end shortly, but I just want to touch on, and then we'll take questions. How does this vaccine work? Because that's sort of led to some confusion, is that, well, hold on a moment, this is messenger RNA, can it convert to DNA? Can it also? That's absolutely not true. But these messenger RNA vaccines have been around for a number of years. Ebola was one, but the whole idea of messenger RNA vaccines was even around when I was a PhD student, which was quite a while ago. Because the concept here, guys, is how viruses work. Because viruses are RNA virus, like COVID. So viruses are either DNA or RNA virus. And what they do is basically, as you can see from this slide here, is that their RNA will hijack the cellular machinery to make viral protein. So COVID-19 vaccine work exactly in the same way as the virus itself. So that's part of what how these vaccines work. And I should point out, don't forget, vaccines are made in a wide variety of different ways. Vaccines can include the entire sort of microbe, but a different version of it, which is milder. It can include, for example, a portion of the microbe. They're called subunit vaccines. So there's a whole host of different types of vaccines that are out there. One thing that's really important is to talk about the side effects. And this is where there's been a lot of information on the idea that there are, myocarditis, there's heart problems, and there's blood clotting. And it is true. These things do. And it's, again, as I say, it's all about risk, but it differs. And what's quite interesting, I'll give you just one example of the blood clot situation. So for the AstraZeneca vaccine, and again, look at the data, it's really important. It's 4 in every million. And so that's by 0.004%. Interestingly, if you smoke, blood clotting is 0.18%. But more importantly, if you get infected by COVID, blood clotting is at 16.5%. So while COVID-19 and the vaccine do have side effects, it's really important to look at the risk and the proportionality. I just mentioned this about pregnancy because now there's more and more data. Initially, the idea of when the clinical trials were done, clinical trials involved a whole host of people, both men and women, but for the young women, they were advised, please don't get pregnant because we don't know what the situation is. However, a small cohort of those women did get pregnant. and they were followed through, both the placebo group and the vaccinated group, and no difference was found between vaccinated and not. And now there's been a whole host of studies to show vaccination doesn't impact on the mother or the fetuses. And more importantly, and more worrying, is that if you get COVID, particularly in the last trimester, it can lead to severe problems. And finally, about mutations, and this is why we need boosters, because viruses can mutate, like for example the flu, which folks have every year because they change their coat. And so what that means is that antibodies are very specific. They're a bit like a lock and key, and if you got your key in the door, imagine if you drop your key and it has a slight nick in it, it can no longer work in the door. Antibodies are really that specific. So when you have a mutation, antibodies may not work. But what's quite interesting is that T cells may still work, because T cells see a different part of the virus. And that's why we need boosters. And the studies have shown that having 2 jabs of the vaccine gives you around 30–40% with this new variant, Omicron. But by having a boost, it's able to improve the efficacy up to 80%. And the idea of boosters is not nothing new to vaccination, because, for example, every year we have the flu jab, and also, with the tetanus, you have that every 5 to 10 years. But I know, again, there's this discussion about that. So to summarize, what I hope you've got an idea of is how important our immune system is. The challenge for our immune system is that if you get infection, how quickly can you generate a response before the pathogen takes over? And that's really one of the problems. And that's why vaccination have proved an effective measure in terms of public health, and also for one's survival. There are indeed side effects, and it's really about looking at the numbers. So I'm going to stop there. Again, I'd like to thank you all for giving me the opportunity. And we've got about 25 minutes or so, where I can take any points, questions, etc. But, thanks again. What I'll do is I'll stop sharing my slide. Is that okay?
Yeah, that's perfect. Thank you, Dr. Palmer.
Okay, brilliant. So yeah, let's have a discussion. Thank you.
So, yeah, like we said, if anyone's got any questions, just pop them in the chat for us and we'll get round to answering those in a bit. But we have got some questions already set up for you, Dr. Palmer. So you spoke a little bit about the difference between natural infection and the immunity you get from that versus vaccine-induced immunity. Yeah. How long does immunity from natural infection last compared to vaccination-induced immunity?
So that's a good question. And that really varies, because, and that's really the problem with what we know about vaccine induced immune response is that for the majority of people, you'll generate an immune response. And studies have shown it's reasonably long lasting. There's some studies shown 9 months and even longer. The difficulty, however, if you get naturally infected, is the response will vary. And more importantly, your response may not be sufficient. So yeah, and so think about it this way. This is particularly amongst our older, relatives, family, and friends. You remember in the first 2 waves of the disease, it was severely impacting on older folks. And that's why they were the first cohort to be vaccinated. And what's quite interesting is it was really surprising in the clinical trials that even if you're older or if you've got a comorbidity, is that you're able to generate a reasonable immune response that provides protection. Whereas if you got naturally infected, if those cohort got naturally infected, they sadly will be the ones that would be in severe trouble, because their immune system is weak already. And by the time they can generate an immune response, the vaccine has taken over. That's not just seen in older folks, but perhaps some of you are aware, and I've spoken to some friends last week, consultant that in Barts and other hospitals, a number of ICU patients are the ones that are unvaccinated.
So it's a case of, if the immunity's natural, it's obviously not going to be as strong as, and you don't know exactly what it's going to be like you would with the vaccine.
Yeah, you won't know what it's going to be until you get ill.
Yeah.
And the difficulty is that it's all about, looking at the data and deciding, it's a risk. I'm football nut, so I love football. I'm an Arsenal supporter. Yeah. And what's quite interesting is, there's some footballers that have taken the vaccine, some that haven't, but, a number of footballers have had COVID. And I know this, from Arsenal players, I read and watch about them, is that they're all fit. Premiership players are probably the most fittest, but isn't it interesting, the rate of which they come back to play the game? Some will come back after a week, others are still finding it difficult. So again, even if you're reasonably fit, and I should point out the dreaded situation of long COVID, which is affecting the numbers are over 1 million. It's about 1.5 million of long COVID.
Yeah, no, it's a very good point. So sort of looking at the future then of the COVID vaccine, should we expect to sort of be having boosters every year?
I don't know. I can't predict. It looks like if you've got the booster, that might be, reasonably sufficient, but it's difficult to say either way.
Yeah. Okay. So you spoke about the safety of the vaccine not being compromised, obviously due to the accelerated process of it being created.
Yeah.
Do you see the future of vaccines sort of being the same, where to be created in the same kind of time period, or do you think this is like a one-off case?
It could be. This is how things are done. You have to remember the whole process of the vaccine safety and vaccine design started really earlier on, because that technology already existed. And so, for example, with Ebola, so a large number of research, large number of safety on all that aspect had already been done. So we wasn't literally starting from scratch. Mm-hmm. But nevertheless, as I said before, I think the biggest impact on why in terms of the vaccine being used was the incredible number of people that came forward. I've got friends who do drugs design, and they say that's the hardest part, to get volunteers. To get volunteers to do clinical trials is really difficult, and that's the slow process. Mm-hmm. Whereas, thousands of people, so they just felt it was a social responsibility. Look, COVID is causing a real problem. And I remember colleagues who worked at the NHS, they were just getting inundated from people who say, yeah, I'd like to volunteer, take part in the trial.
I suppose it's a case of, this is something that was affecting everyone, wasn't it? And everyone wanted to sort of get involved and beat it.
Yeah, and so everybody wanted to, to get involved and try and help.
Yeah. Okay. So people, people are worried of getting the vaccine, obviously, because there's some uncertainty around sort of the long-term effects and what it might do because of the short-term testing.
Yeah. I guess, the one of the things about the immune system we know is that if there's going to be any effects, the effect is almost relatively immediate. So, for example, where there were cases of very small proportion of getting blood clots, or again, very small folks getting heart symptoms. So the generation and how the immune system works, it can't have a long-term effect, because if it took too long, you'll be overrun by bacteria, viruses, and parasites. So the nature of our immune system is such that it has to deal with the microbe ASAP. So if the vaccine was going to have any adverse effect, which is what we're seeing, it has to be relatively immediate. So,
Right.
and what we're seeing, and it's really important because what we need to do, and I think everybody, and I did the same when I was looking at the information and the data, is compare the two. So if you're doing any studies, compare if I get the vaccine, what's the response that I get with the vaccine compared to the virus? So what's the long-term effect of what are the potential long-term side effects of the vaccine? But you must also ask, what are the long-term side effects of the getting virally infected?
Mm-hmm.
You see, and that's where one can then, look at the risk and then come to their own conclusion.
Yeah, and you made a good point. Is that the whole purpose of this isn't to try and convince anyone, but just to give.
Oh no, it's to folks need to look at the data and work out what's the best thing. And I know at the time the government was looking at mandatory, and I think overall, I think the consensus for most folks was, okay, vaccines play an important role, but I think overall, most people, said, yeah, what the government has done is seemed to be the sensible thing in terms of making a U-turn, because in the UK, all vaccines is done on the basis of choice, where people make their own decision. And the concern I know many people had was by making it mandatory for health workers, is that actually undermining the importance of taking the vaccine. So I know many people were thinking, now by making it mandatory, is that, it's all about voluntary. By discussing and people weighing up the circumstances, they can then come to an informed choice.
Yeah, you've just answered my next question there. What the reasons were for such unrest for care workers against the mandate? Because obviously, for care workers, we already have to have specific vaccines anyway to work, patient facing. So it is interesting that there's been so much unrest regarding the VCOD and that whole.
You're right, and part of the unrest related is, I did some events with NHS staff and just talking to them about it, and data from the NHS, they noted that in terms of the vaccine uptake, they noticed that staff from diverse communities showed a degree of reluctancy, and what people have failed to understand is the reasons for that, and there are legitimate concerns, not just amongst health workers, but amongst diverse communities in general, and principally related to a lack of trust, the issue of medical racism, and only this week you may have seen the race inequality report with regards to health. So their concerns are legitimate, and it's really about discussing what those concerns are, and talking about for folks to address what their concerns, and more importantly, for those concerns to be heard. Because I think part of what government and other people are doing is say, yeah, take the vaccine, and not addressing this. And the reason why I say that, and that's partly one of the reasons why I got involved in discussing it, was when the government announced, we're going to roll out the vaccine. This was well over a year ago. They weren't really, messaging, targeting different communities. Data was already out that diverse communities were reluctant to take the vaccine. That data was out before the vaccine was generated. And so there were no discussions taking place to talk about why that is. And I remember, got involved with folks from Brent and folks from Hackney, who that folks were able to be listened to, their grievances and their concerns, give them a platform.
Yeah, you've touched on it a little bit there, but what do you think? sort of in the sort of those diversity groups and those BAME communities, let's say, the initial thoughts were regarding the vaccine, and do you think their perceptions have changed after those discussions?
Well, part of what it is was the incredible. I mean, this is really something that I think scientists have not recognized is the importance of public engagement. So, you know, scientists, we are, you know, ivory towers, and we publish research, and those research get published in scientific journals, and they're read by other scientists. So we're in our own bubble. I think there's been a reshape and a rethink in that, you know, we have to make sure we can translate our research and what we do so that the general public can understand. Because what happened, I remember, was you know, was a series of misinformation and misdirection, and partly aligning to folks' natural concerns. So there's so, you know, various conspiracies. So, you know, I'm sure some of you would have seen this, you know, and things like, as I said, it contains gelatin, so which was untrue. It can alter your DNA. Oh, it's magnetized, and all these, and so that has a greater spread, and so misinformation was better than information, and equally explain it in a language people can understand. So again, not everybody listens to Radio 4, for example. And so it's really about communicating and giving people the information to say, okay, here's all the information. And here's, this is how, you know, the clinical trials were done. This was how the vaccine was made. This is how it works. These are the side effects, and acknowledge there are some side effects. But also, I think acknowledging, and I remember doing this earlier on, acknowledging the legitimacy of folks' concerns.
Yeah, and it's such an important point again that you raised, that, you know, in today's society, in the internet age, there's so much fake news, and people will believe anything they've read without any sort of peer reviews or, you know, even any reference to it, and they'll just believe anything that they read.
And you're right, Adam, and that's really been the struggle. So I've been on debates, and someone will say, "But Donald, listen, you know, somebody's said they've got this, and they've turned into a snake or something." And the difficulty, as an academic, I have to confine myself to the rules of academia. In that, as an academic, I've got to comment and use peer review, because that's our modus operandi. So the difficulty is, you know, I can't steer to say and disagree with that because I don't know it. You know, where's the evidence? So I think what's important, what we all need to do as scientists, we need to find better ways of communicating, but equally, we've got to, in general, make sure we don't we scrutinize. I'll give you one perfect example, Adam, and this is really important. So I remember earlier on, one video that did the rounds was groups of school children running out of a school in Africa. It's Nigeria, and so the commentary in the background was, oh yes, these are children that have been forced to take the vaccine, but they're running away because the vaccine is dangerous. Again, what was interesting, that was actually a story several years ago of a potential bomb or an explosion in the school. That's why people were running. And the question I've often asked is, why are they targeting, you know, our community and our diverse community who have legitimate concerns? And what that does, it feeds into those concerns. And so I think we need to think of ways of how to combat that, as you say, fake news.
Yeah, and I suppose it's about context sometimes as well, isn't it?
Yeah.
So one of the questions we've got in from the chat, so one of them said, my parents are anti-vaxxers and I'm torn between the vaccine and respecting their wishes. I'm an ethnic minority and there's a lot of hesitancy within our community. I'm probably going to get it, but keep it a secret. Have you heard of this before?
Well, one, it's not just with ethnic minorities, and that's a really good question, but it's also split families. It's someone told me this, and I've been reflecting, and I'll share this with you to see what you all think. I think it's worthy that you can all reflect on this. But my friend said, Donald, the vaccine's a bit like Brexit. So people voted for Brexit for a number of reasons because there were some grievances or whatever, and I don't want to get into that debate. And he said to me, Donald, I wonder if the vaccine is really a proxy. It's not the vaccine, but this is a case where people can say yes or no. And again, like Brexit, it's caused family divisions, and no doubt that's the same. And it's a difficult one because people, as I say, it's a matter of choice, and it's how folks, came to those conclusions, and it's a difficult one. But I think this may sound like a cop out, but it's really by having a conversation where, as I said, that's what myself I've been doing, and I engage and interact with a host of different people, and it's by having that conversation.
And I suppose regardless of what your opinion is, you need to facilitate for other people's, don't you, and not hold it against them or anything, things like that. Just I know it seems very black and white that yes, you can get the vaccine, or no, I haven't got the vaccine, but everyone has their own individual sort of ideas and beliefs behind it, don't they?
Exactly. So what you should do is whatever questions or any individual have, they shouldn't be judged. It's literally a case of how did you, what's this you're asking for, and no question is, and I say this to students regardless of COVID, is that there's no such thing as a stupid question. There is one, is when you leave and don't ask it. So there's no such thing as a stupid question. It's literally a case of what is the information, what it's about. I mean, I'll give you one example. I did an event last week. There's myself and another an Indian doctor and a Muslim cleric, and we were just chatting, and they said to us, and this is 2020. So the vaccine and the virus has been around for a while, and they said it's the first conversation they've had where they're able to really understand what's going on. And so that's what's happening, Adam, is that those communities are crying out for information, but no one's disseminating. So only last week I was doing a Zoom call, and the feedback was, yeah, that's really interesting. I'm still going to contemplate it, but yeah, it's maybe, I mean, it was a compliment. They said, you guys should be doing the press briefings, which was nice. But that, for me, is the key, is that I don't think people are either for or against the vaccine. I think people just want information.
Yeah, they feel a little bit like they've been left in the dark a little bit.
Exactly.
Yeah. Okay, so just the one more question then from the chat. Do you think the coronavirus situation has changed the way that worldwide healthcare is going to approach pandemics and epidemics in the future? And I'll add to that, or even just the way that healthcare is run at the moment in this country?
Well, you made a really good point. So in terms of, so there's a couple of points. So in terms of pandemic and epidemic, is that if we can get, this could be a bit political now, so if we can get governments to think more on a global scale rather than a nationalistic scale. So Gordon Brown wrote a brilliant article in The Guardian a couple of years ago about the vaccine and trying to think about it more as a global support and help one another rather than nationalistic. So I'm hoping in the future, and if you ever get, I can't remember the guy's name, it escapes me. There's 2 or 3 authors. It's about how smallpox was eradicated. And if you read that was the blueprint. I can't remember the authors. It was a while since I read it. but it is basically leaders of all the world got together and were able to eradicate, which was a terrible disease. That was really true leadership, in the sense that how to conquer pandemics really require on a global scale where all countries are involved, where I think this time around there were people talking we're the fastest, no, we're the fastest, and that hasn't helped. In terms of health, I'm hoping, both in health but in societal, that because what COVID has highlighted is the existing health inequalities that's in our society. And so more importantly, I'm hoping organizers, community leaders will say, no, we can't go back now. It is now a case where we need to address these inequalities, such as, Black women dying in pregnancy at around 4 to 5 times the rate. I mean, that's unacceptable. And I think that's, for me, where I see the future. Is people like you young people, can now say, hold on a moment. These are, and it's basically, if I'm allowed just one more minute, and I shared a platform with some young people. Well, I was listening, and I mentor a couple of young people, and I see what you guys are doing will be the game changers, because it's a bit like, there's 2 real pivotal moments that I've never experienced when I was young that you guys have, is George Floyd and COVID. And it's almost created this perfect storm where your eyes are now open. And it's now a case of, regardless of where you're from, you're now saying, hold on, these inequalities now need to be addressed. And that's where hopefully I see you guys taking that baton on that gusto to really address those.
Yeah, I love what you said there about, it being a competition. We've got this many vaccines. I think it needs to be looked at in a way that until everyone's beaten it, no one's beaten it.
Yeah.
In the same way that smallpox, until it's gone, until it's eradicated, there's still a chance that people are going to be killed by it. Well, thank you, Dr. Palmer, for your time. I personally found that very informative. I'm sure everyone else.
Thank you. No, thank you for giving me the opportunity.
I'll just double check that there's no more questions. Yeah, there's one more question. And just about vaccine safety for children. Obviously, a lot of the population especially that age, haven't been offered the vaccine yet. Where do you see that heading?
I think at the moment, I believe there are still undergoing studies. And I know JCVI, they were saying, and I need to check this, but when I last heard, they were saying that they're still looking for more evidence in terms of children. I think the US have got vaccinating with young children. But I think the JCVI, this is the UK Joint Vaccine Committee, are still looking at the data and at the evidence around that. Okay. I guess the challenge really is that that's one debate that's still ongoing, but depending on the situation, I'm aware of friends or whatever who are looking at vaccination, because there's still members of older folks that have not been vaccinated yet. Yeah. So while yet we may say less young people, but there's still older individuals. And finally, one last point, if I may raise, but you've really highlighted this to Adam, thank you. It is the major real problem for young people, for I'm talking children, it is, okay, could be COVID-19 or whatever, is that what's happened with the discussion around vaccines and mistrust and misinformation is that childhood immunizations is at an all-time record low for 10 years. Now, this is real major concern, because we're not talking now COVID, we're talking of diseases like measles, etc., which could now start to appear subsequently. So that's a real concern, that's something really we need to address.
Yeah, and I think we have some Scottish students in the call. Do you think that is, is it going to be different for children in Scotland, or is it just the UK as a whole will probably move in the same direction, do you think?
I think UK as a whole will move in the same direction, I think, with regards to COVID. And I know that doesn't help because it makes it slightly complicated. But everyone's looking at the same data. So hopefully they'll come to the same conclusion. Yeah.
Okay. Well, again, thank you for your time. Thank you for it. Obviously, I can't speak for everyone, but I found it very informative. And I think, every student should have access to this kind of information readily as well.
No, indeed. Indeed. So for example, and this is what I meant. So in January, there was myself. In fact, there was a nurse from Birmingham, Jennifer Pearson, who you may or may not know. She's a regional lead in Midlands. She's a chief nursing officer. Myself and a few other people, we did a Q&A for a school, and they were secondary school children. It was supposed to be for about 45 minutes. That went for an hour and a half. And they were literally, they were incredibly polite, but they're asking loads of questions.
Yeah.
And the feedback was, wow. And we obviously got parental consent, but the feedback has been, it's brilliant. And the kids enjoyed it because, again, everyone, young or old, have heard about it and and have an opinion, but more importantly, have got questions they want answering. And for many, they said, no, we've never had the opportunity to ask questions in a safe environment. So we did that for a school in London. And yeah, I mean, absolutely brilliant.
Yeah.
So no, do continue the conversation.
Yeah. Well, we'll let you go now. Thank you again for your time.
No worries, guys. And if there are questions, I think Eliam's got my email. So the questions, you can send them to me and then I'll get round to answering them.
For sure. Thank you so much, Dr. Palmer, for your time.
No worries. So listen, you guys, take care. I know the wind, I don't know it's like in Birmingham, but in London, the wind is kind of scary. So, take care. So I'll leave you because I know you're going to have your own
thank you.
discussion. All right. Take care. And thanks again.
Thank you.
Bye.
Okay, so